Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on differentiating sine and cos, and in this video I'm just going to be taking you through an example of an application of differentiation with trig. So what I'm being asked to do, I'm being told that the point P lies on the curve with equation y equals 3 cos 2x minus pi over 2 and has an x coordinate of pi over 3. Find the equation of the normal to the curve at the point P. Okay, a couple of things just to pick up on to begin with. First of all, 2x minus pi over 2, and the x coordinate is pi over 3. It means we're in radians mode. We must be in radians mode. Calculus with trig has to be in radians mode. So I'm being given the equation of the line and asked to find an equation of the normal at a given point. So, what's the two things you need to find the equation of a straight line? Go on, say it out loud, shout it out loud at the video. What's the two things you need to find the equation of a straight line? A point and the gradient. Do we have a point? Well, we have the x coordinate, we don't have a y coordinate. So the first thing that we're going to do is we're going to say that x is pi over 3, and therefore y would be 3 cos of 2 lots of pi over 3 minus pi over 2, which is 3 cos of pi over 6. Cos of pi over 6 is root 3 over 2, so it is 3 root 3 over 2, which means that my point P, where I'm finding the normal, is pi over 3, the x coordinate that I was given, and 3 root 3 over 2 full y. So that is my point P. So there's my point. What's the other thing I need? The other thing I need is the gradient. If I know the equation of a curve, how do I get the gradient? I need the gradient function. I differentiate. So I have y equals 3 cos of 2x minus pi over 2. So how do we differentiate that? Well, cos is going to differentiate to negative sine. So by dy by dx is going to be negative 3 sine. The bracket won't change, so 2x minus pi over 2. But because of the chain rule, I'm multiplying by the differentiated bracket, which is 2. So multiplying by 2, which gives me negative 6 sine of 2x minus pi over 2. The pi over 2 inside the bracket, it doesn't affect how we differentiate, because if you think in terms of transformations, that negative pi over 2 is just moving the graph over to the left by pi over 2. It isn't affecting the gradient of the curve, it's just moving it, it's translating it. Now, I have my expression for dy dx, I need to find the gradient. So I need to substitute my x value into dy dx to find the gradient as a number. So if x equals pi over 3, then dy dx is going to equal negative 6 sine of pi over 6. I know it's pi over 6 because it's the same value as I substituted in here. Sine of pi over 6 is a half, which means that dy dx is negative 3. Now, what's the crucial thing to watch out for here? I've been asked for the equation of the normal, not the tangent. Now this would be the gradient of the tangent to the curve at that point. So because I'm being asked for the normal, I need the perpendicular gradient, which is the negative reciprocal, so positive 1/3. So negative 3, flip it over, change the sign, positive 1/3. And then I have everything that I need to find the equation of the straight line, because I have the gradient, and I already know from here that the coordinate of P is pi over 3, 3 root 3 over 2. And if you're thinking at this point, oh yeah, I've got this, I don't have to watch the rest of it. Watch the rest of it, because there's important information coming up about the form that you give your answer in. So, general equation of a straight line, go. Y minus y1 equals m bracket x minus x1. So y minus 3 root 3 over 2 equals 1/3 x minus pi over 3. And normally what I do when you've got a fractional gradient here is you multiply by the denominator to make it nicer, and that's great, but in this case it's not going to make it all that nicer because I've got this over 2 as well. So what I'm actually going to do is I'm going to multiply both sides of the equation by 6, because what that's going to do is deal with the 3 and at the same time deal with the 2. So multiplying by 6, I'm going to have 6y minus, now if I multiply this by 6, I'm going to have 18 over 2, so I'm going to have 9 root 3. And if I multiply the right hand side by 6, 1/3 times 6, I'm going to have 2, and then the bracket. Expand that out, so 6y minus 9 root 3 equals 2x minus 2 pi over 3. And I'm just going to write that in the form ax plus by plus c equals 0, which would be 2x minus 6y plus 9 root 3 minus 2 pi over 3 equals 0. And if I was going to state the values, I would say that a is 2, b is negative 6, and c is that whole constant value there, which is 9 root 3 minus 2 pi over 3. Okay. So finding a normal, just like before, you need a point, you need the gradient. We substituted x into the original equation to find y, that gave us our coordinate. We differentiated to find the gradient function, substituted in x. Crucially, that would find us the gradient if we were looking for the tangent, but we're looking for the normal. So we took the negative reciprocal and then cracked it into the general equation of a straight line. And that's job done. I'll see you in the next video.